Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 9 from the International A-Level Edexcel June 2021 P3 exam, Pure Mathematics P3. And this question here is about the addition formula of trigonometry. You have a expression which is 12 sine x minus 5 cosine x, and we're asked to express it in the form r sine x minus alpha, where r and alpha are constants. R is positive and alpha is between 0 and pi over 2. Give the exact value of R and give the value of alpha in radians, of course, it's mentioned here in radians anyway, to 3 decimal places. Okay, so now we have to express this expression, which is 12 times the sine of x minus 5 times the cosine of x, in the form of R, some constant, times the sine of the angle x minus alpha, and alpha is in radians. That's what we need to do. Okay, so this has to be identical to that. Now what we're going to do is we're going to use what are called the addition formulae, which are in the formula book, to write this in a form where you're going to have the sine of x and the cosine of x as separate terms. Okay, and those formulae are formulas which you can find very easily in the formula book. So I'm just going to have copied it already. This is the relevant one for sine, the sine of an angle plus another angle, okay, a compound angle. And you can expand that. You can think of it expanding into sine A cosine B plus or minus cosine A sine B. So if there's a plus between them, there's a plus between the expansion. If there's a negative between the angle, the compound angle, there's a negative sign between the expansion. So please, the thing that a lot of students mess up with something like this, they think this can expand as sine A plus sine B, or sine A minus sine B, and that doesn't make sense. Sine on its own, without an angle, doesn't mean anything. It's not like x times, A plus B. It's not like x times A and x times B. Sine, it's not sine times A and sine times B. It's the sine of the angle A plus B. The A plus B is part of this whole function, right? When you want to express it in a form where you have separate terms for sine and cosine, you can express it using this addition formula. You don't need to know the derivation for this. There is a derivation for this. I'm not going to go into it right now, but looking at the formula book, you'll see this. And after you've done a few questions in P3 in this chapter, and when you've been revising for your exams towards the exam, this should be stuck in your brain. You wouldn't really need to even look at the formula book, but in case you want to make sure, it's in the formula book, and that's where I took this from. So basically what we can say, therefore, is that the 12 times the sine of x minus 5 times the cosine of x is identical to r times the sine of, now look, the a is in the place of the x and the b is in place of the alpha, right? So it's going to be r times sine of x cosine of alpha, and there's a minus here, there's a minus between them as well, so minus, and you've got the r multiplying both of these terms, so I have to write r again, and this is times the cosine of x times the sine of alpha. Okay, so that's what we have. This expansion becomes that. Now we want to find the value of r and the value of alpha. Now a very simple way of doing that is to compare the coefficients of the sine x and the cosine x. So for example, if I look at the sine x on this side and the sine x on that side, and if I look at the cosine x on this side and the cosine x on that side, then that should help us to work out what to do. So if I compare the coefficients like we do normal identities, the sine x's on both sides, like sometimes when we have polynomials and we have to compare the coefficients on both sides of the identities, we compare the x cubed with the x cubed on this side and the x squared with the x squared on that side. We're doing exactly the same thing this time, but with the coefficient of sine x. So on the left side of this identity, the sine x has a coefficient of 12. So on the left side, it's going to be 12, and that's equal to the coefficient of sine x on the right side of the equation. It's like sine x is multiplied by r and by cosine alpha. So that's 12 equals r times cosine alpha. So that's one equation we formed from the identity, from comparing the coefficients. And now we can also compare the coefficients of cosine x. Okay, we compare the coefficient of cosine x. On this side we got a 5. On this side we got r sine alpha. R sine alpha, because the cosine x is multiplied by r sine alpha, and here it's multiplied by 5. The minus is the same in both, so we don't have to worry about that. Okay, if I put minus here and here, it's going to cancel out anyway. So now we can say, okay, that means that the cosine of alpha is equal to 12 over r, and the sine of alpha is equal to 5 over r. So there's a number of ways we can continue from here. One way is basically to make a right angle triangle and say, okay, let's call this the right angle, let's call this alpha, and we know that the cosine of alpha is 12 over r, so adjacent over hypotenuse, and the sine of alpha is 5 over r, so that's going to be opposite over hypotenuse. So we can look at r using Pythagoras. We can say r squared is the sum, the r squared is equal to the square of the sum of the two other sides, because this is the hypotenuse using Pythagoras' theorem. So r is going to be the square root of 12 squared plus 5 squared, which is going to be 13. It's a 5, 12, 13 triangle. Okay, so r is equal to 13. That's the value of r. It's an exact value of r. Okay, there's no root form here. Okay, it's exactly 13. And the tan of the angle alpha, if you want to find what alpha is, the tan of the angle alpha is opposite over adjacent. So 5 over 12. So alpha is going to be, if you work that out, okay, so we're going to make sure that we are in radian mode, and we are in radian mode. So we've got an r there. If we weren't, we can press shift, menu, angle unit, and change it to what we want. We're already in radian, so that's fine. So now we're going to say inverse tan of 5 over 12. And that gives us 0.39479. 0.34979. Let's make sure. Oops, I always do that. All right, what I'm going to do here is I'm going to do the following. I'm going to capture the screen and paste it. Okay, normally you have that calculator next to you. When I switch from the calculator to the page, the calculator disappears. So that's why sometimes I don't write it down correctly. So alpha is equal to, I've got it here now, 0.39479. It goes on, I don't have to write all of it. Okay, thank you very much. Sorted that out. Now we can write that to 3 decimal places as required in the question. Okay, so that's going to be alpha equals 0.395. So now we can say that this expression that they gave us, 12 sine x minus 5, 12 sine x, sorry, minus 5 cosine of x is equal to, r was 13, and it was in this form, it was r sine x minus alpha. So 13 times sine x minus alpha, which is 0.395. So there we have the expression expressed in the form that they required us to express it. That's a very useful form for us to express it in, as we'll see in the subsequent questions where we're going to have to use this. Okay, so I'm going to go into part B now. Okay, now on to part B. And it says the function g is defined by g of theta is equal to 10 plus sine plus 10 plus 12 sine of 2 theta minus pi over 6 minus 5 times cosine of 2 theta minus pi over 6, where theta is greater than 0. And it says find the minimum value of g theta. Now they didn't say hence or using what you found in part A, but that's exactly what we've got to do. Because if you look to see what we did in part A, and any question where they ask you to do something like this in part A, for sure the other parts of the question will be related to what you've done. It's pretty much certain of that. So we can see here that this, let me just change it to this here, okay, is of the same form as this. 12 sine of an angle minus 5 cosine of the same angle. 12 sine of an angle minus 5 cosine of the same angle. So we can use this, identity that we formed, or this expression of how we expressed it in this form, and apply it to this. So I can rewrite g theta. I can say therefore g theta can be rewritten using what we did in part A as 10 plus 12 times. Now we're going to have, not 12 times, sorry, 13 times. Okay, because this is equal to this. 13 times, and we're going to have the sine of, and we're going to have, instead of x minus 0.395, the angle here now has become, our x is now become, you see the x here has now become that. So the x is now 2 theta minus pi over 6. So this becomes 2 theta minus pi over 6 and then minus 0.395. That's what this becomes. Okay, this is the same as that now. Okay, so replace the x with 2 theta minus pi over 6. Then it becomes, 13 sine x minus 0.395. The x is replaced by 2 theta minus pi over 6. So now we can say that this expression is the same as this expression. They're exactly the same. Okay, using the results that we got in part A. So then we come to think about part B, part 1. It says, find the minimum value of g theta. Okay, so when you have, 10 plus 13 times the sine of any angle. Okay, I'm just going to say let 2 theta minus pi over 6 minus 0.395. Let's call that A. So let's say it's sine A. Okay, the sine of A has a maximum value of 1 and a minimum value of minus 1. The maximum value the sine of any angle can be is 1, and the minimum value can be minus 1. So the minimum value of g theta is going to be when you have this becoming minus 1. So it's going to be 10 plus 13 times minus 1, which is 10 minus 13, which is negative 3. So we can say that the minimum value of g theta is going to be negative 3. That's a minimum value. So that's the answer to part 1. If we said the maximum value, we would say 10 plus 13, because it will be the maximum value of sine of any angle is 1. So this is the sine of this whole angle. Its maximum value is 1. Its minimum value is minus 1. And for part 2, it says find the smallest value of theta at which the minimum occurs. So we can say the minimum occurs, okay, when the sine of the angle we chose is equal to negative 1. So when the sine of the angle, which we called it A, but it's actually 2 theta minus pi over 6 minus 0.395, when this angle is equal to negative 1, that's when the sine of this angle is equal to negative 1, that's when this minimum will occur. So we're going to find the smallest the first time that occurs. So let's solve this equation. Well, we know that the inverse sine, so we have 2 theta minus pi over 6 minus 0.395 is equal to the inverse sine of negative 1. Now the inverse sine of negative 1 is 3 pi over 2, because the sine curve goes like this, and like this. It equals negative 1. The first time it equals negative 1, is at the angle 3 pi over 2, 270 degrees. Okay, so that's the first time in the positive direction that it equals minus 1, and it says the smallest positive value of theta. So that means this is going to be 3 pi over 2. So all of this, 2 theta minus pi over 6 minus 0.395 is equal to 3 pi over 2. So we can say that 2 pi is equal to 3 pi over 2 plus pi over 6 plus 0.395. Okay, so we can add those together. So we've got that already here. So plus pi over 6 plus pi divided by 6, and also plus 3 pi over 2. And that gives us 5.63077. So 2 pi equals 5.63077. Continues on like that. So theta therefore is this number divided by 2. You divide this by 2, you get 2.8153. 2.8153. 2.8153 goes on, and it didn't tell us how to give the answer. So I'm just going to give it to 3SF. So theta is equal to 2.82. Okay, I've written it to 3SF because it didn't say anything else here. In degrees, I'd write it to 1 decimal place. In radians, we can just write it to 3SF if it's not mentioned otherwise. Okay, the last question said give your answer to degrees and 3 decimal places. I've left this to 3 significant figures because it didn't state anything else. So that's the answer to question B, part 2 of 9 from the P3 exam. I'm now going to go on to B part, question part C, 9 parts. Okay, now for question 9 part C, we're told that the function h is defined by h of beta equals 10 minus brackets 12 minus sine beta minus 5 cosine beta squared. Alright, now again we can see there's a connection between what we have here. Okay, there's a connection between this part of what we have, what they gave us, and what they ask us to change its form into this form earlier in the question. So we can see that there's definitely a link between those two things, and we're going to use the result that we got earlier in order to solve this problem, because it's easy for us to find the range of something that looks like this, to find the value of something like this, rather than to find the range of values of something that looks like this, because this is like 13 times the sine of something. So first of all, let me just write the function h beta in terms of this format here. So you're going to have 10 minus, and you got 13 times the sine of beta instead of x minus 0.395, and that's all squared, that part. Alright, so this is the function h of beta, and as I said, it's easy for us to find the range of something like this rather than the something in this form here. Okay, because we know that the sine of an angle, let's just say the angle beta minus 0.395, I'm going to call it angle A for now. The sine of angle A can have a maximum value of +1, a minimum value of -1. Okay, it can also have a value of 0. As we know, the sine curve fluctuates between 0, 1, -1, 0, and so on. Okay, so now what we can do here is we can think about the extreme values that this can be. All right, so let's see when the sine of the angle is equal to +1, we'll have h of the angle, or h of beta, is equal to 10 minus, you're going to have 13 times, and this is going to be sine of this is going to be 1, as we said, and that's going to be squared. So you'll end up with 10 minus 169, because 13 squared is 169. That gives you negative 159. So that's one of the extreme values. And the thing is, if we take sine A to be -1, what's going to happen here, you'll realize that -1 is going to be squared, and we'll end up with exactly the same thing, because you'll have 10 minus, and this will be negative 13 squared, because you have 13 times -1. If the sine of this is equal to -1, you'll have 13 times -1, so you'll end up squaring that, so you'll end up with the same thing, which is 10 minus 169, which is going to be negative 159. So it gives you the same value, but we have to realize that it's not going to stay this whole value the whole time. It's going to be between certain values. And now what we can think about is this, that we have this function 10 minus 13 times the sine of beta minus 0.395, and this is going to be squared, this part. Now what we can see is this function is always going to have something being taken away from 10. It's going to be 10 minus something. Okay, 10 minus whatever's in this bracket, then squared. And what you're going to take away from 10 will never ever be negative, because you're going to square this. This is going to be squared. All right, so even if you end up with a negative value, as we saw inside the bracket, it's going to get squared. It's going to become positive. So you're always going to be taking away something away from 10. You'll never have 10 minus 10 plus something. It will always be 10 take away something. Now, what is the smallest value you can take away from 10 in this? It's not when sine of this is equal to -1, because that gets squared. It's actually when the sine of the angle equals 0. Okay, so if we take when the sine of the angle is equal to 0, we'll end up with this being 10 minus 13 times the sine, well, 13 times 0, because the sine, if this is equal to 0, 13 times 0 squared, which is 10 minus 0, which is 10. So we can see that the maximum value of this function is equal to 10, and we can see the minimum value of this function, as we saw here, is equal to negative 159. So it ranges between these two values. So we can say the function h of b ranges between the values of negative 159 and 10. Okay, that's important for us to realize this. So sometimes you can find the minimum when you have to square something, or the maximum here in this case when you basically when you have to square this thing. All right, the -1 and the +1 will give you the same result as we saw here. So if putting 0 in there will give us the other extreme, which is the maximum value. Okay, because that's when you're taking away the least amount from 10. When you have 0, when this whole thing becomes 0, that's when sine of the angle is 0. Okay, so it's 10 minus 0 squared, which is 10. So there we have the answer to this question, question number 9. Thank you for watching. We've now finished this paper. Any questions you want to see from this paper will be in the playlist that should appear at the end of the video somewhere in this area. Other questions you might want to watch from this topic of trigonometry and addition formulae, you can find it in the playlist that should appear in this area over here. You can subscribe to my channel by clicking on the link in the middle, and any questions you want to watch from different papers like P1, P2, P4, M1, S1, also IGCSE kind of papers, you'll find in the description links that will take you to those material from those papers that I've made. Thank you for watching, and see you soon.